everybody. Today I'm going to tell you about my genetic disorder. My mouse out of the way. I had Mucopolysaccharidosis Type 1. It is the most severe of the Mucopolysaccharidoses. There are several different types that are less severe. So this was first discovered by German pediatrician Gertrude Hurler. So this particular Mucopolysaccharidosis Type 1 is named Hurler syndrome, and then there are several others that are less severe that are also named after her and another person who helped her discover this syndrome. And, back in 1919, it was okay to call it gargoylism, which we don't call it that anymore. So we have the MPS type 1H, which is my disorder, Mucopolysaccharidosis type 1, and then we have in diminishing severity the MSH1H /H, which is this guy Skene syndrome. He was the one that helped her name and describe the less severe forms and the rarer forms of this phenotype. This picture doesn't have anything to do with my presentation. However, I just put it on there so that you guys would know that I'm talking about alleles. It happens in 1 in 100,000 births approximately. Everybody is at risk for this. There's no racial or ethnic selectivity with this genetic abnormality. The less severe ones are about 1 in 500,000 births. Just going to go ahead and get all these up here. So the mode of inheritance, it is an autosomal recessive disorder, which means that both parents have to be carriers and have to pass their defective alleles to their offspring before this genetic disorder can manifest. You can be a carrier and you will not show any symptoms at all. However, the enzyme that this genetic disorder deactivates, the person that is a carrier will still have production of this enzyme, but it'll only produce at about 50%. But that 50% is enough to let that person live a normal life without noticing that something is wrong or that they even are a carrier for this disorder. So bottom, as you can see, carrier to carrier has to be passed, or carrier to somebody who is affected that is homozygous with the allele. So the location on the chromosome is 4p16.3. That P means that it is on the short arm of the chromosome at position 16.3. So this enzyme is responsible for the production of iduronase, which helps break down sugar and fat molecules in this specified area. The abnormality that occurs when this gene is affected is that there is limited production or total lack of production. And buildup of this can lead to system dysfunction and failure, even death. So the mutation with this disease, and with this disease and where it's located, it is a mutation of the IDUA gene, which is where previous slide was telling you where that gene was located. And it diminishes the function of a protein that produces an enzyme that is alpha L iduronase. And this is located in the lysosomes of cells. So we know from our biology classes that lysosomes are kind of like the cellular trash can, to put it in lay terms. So without this enzyme being in the lysosome, they're unable to break down the glycosaminoglycans. Excuse me if I'm not pronouncing that correctly. So without that, they cannot break down these sugar molecules. So the sugar molecules continue to accumulate. So when there's accumulation, there's a growth. And the inability of this leads to, since this is an inability, it's deficiency of this enzyme. And the sugar molecules, they accumulate in the lysosome since there's no enzyme to help break them down, and there's a buildup. And the buildup leads to the tissue becoming enlarged as well. And so if your tissue becomes enlarged, you're going to end up with a bunch of waste products that you can't eliminate from the cell, and it'll eventually lead to cell death. This is my pedigree of my autosomal recessive. So you have two parents here that are heterozygous, which means they have one abnormal allele and one normal allele. So the normal allele overshadows the abnormal one. And so when they have offspring, you have two that received the normal alleles, two pair, and so they are not showing at all. They are not even carriers. Then you have a carrier here that received one normal one and one affected one. And then you have their fourth child here that was a full-blown affected heterozygous for the trait. And then you would see that they got with somebody, or bred with somebody that had no traits at all, no carrier. So you end up with offspring here. You have two carriers and two non-carriers, and not carrier, not. So they are homozygous for their normal allele. Here, with the homozygous are going to produce homozygous children that aren't going to be affected, and then the carrier, heterozygous and homozygous for non-affected, you end up with the production of two non-affected completely and one carrier. So these carriers here have the potential to pass on their genetic disorder, whereas the ones in blue will not pass on the disorder because they are homozygous for a, I guess you would say, a normal allele or unaffected. Physical manifestations. This is a picture of one that has the severe form of Mucopolysaccharidosis Type 1. Very short in stature, broad forehead. So when the child is born, the genetic mutation may not manifest at birth, but generally very close after birth, within the first 6 months, they have a general manifestation of the signs and symptoms and physical manifestations associated with this genetic disorder. It says within the first year of life, but it's around 6 months to the first year. Some of the physical signs you can read here, but I'm going to quickly go through them. Enlarged head, lips, cheeks, tongue, and nose, which you can see here on this young fellow. Contracture of the ligaments refers to permanent tightening of tissue and tendons and skin. Hepatosplenomegaly, that means that you have an enlarged liver. Hydrocephalus, that means you have a lot of fluid in your cranium. Enlarged vocal cords, that leads to deep voice. Recurrent ear infection, hearing loss, thickening of the long bones, which would be your humerus and your femur. Spinal stenosis, stiffening of your spinal column, narrowing, sorry. Heart abnormalities, inguinal and umbilical hernias are also, Let's move on to the next slide, shall we? Genetic testing for this disease is available with your newborn screening, and that's just a general newborn screening that they do. They'll come in there and take blood from a newborn and send it off, and they'll screen for this within the testing. And when they look for it, they'll look for the change in the alpha-L iduronase gene. Also available from different companies is next generation sequencing, deletion duplication, and NGS deletion delete dupe comprehensive testing. You can do a single gene test or a multi-panel, and the multi-panel test for several enzymes and their activity to see whether they are functioning or non-functioning. You can have an enzyme analysis as well. So I looked up some genetic test and their cost. It can get expensive if you're paying out of top pocket, and sometimes it is not covered by insurance. As you can see, some of this just for one test is $1,100, and this is $900, $1,300. The extended carrier screening panel to see if you are a carrier and further on into your genetic makeup, that's close to $1,500, $1,460. Your genetic sequencing, $1,400, $990, and then this comprehensive thing is $1,600. There is no cure for mucopolysaccharidosis regardless of what you have as far as the severity of the disease. So there are several treatments that you can receive. A bone marrow transplant, which we should generally be familiar with a bone marrow transplant, but when you, under that is the hematopoietic blood cell transplant, and that is tissue taken from bone marrow and peripheral blood and umbilical cord, and it's taken from a healthy patient and transplanted into a patient with mucopolysaccharidosis. It doesn't have to be the type 1, it can be the other types as well if needed. Or another option is enzyme replacement therapy, and as I said before, the iduronase is an enzyme that's missing, so they'll take it from somebody else and put it into the person that's affected to try to counteract the detrimental effects of not having that enzyme, and generally that's done once a week. So since it's not a curable disorder, but using these treatments can make life more manageable. So here are some cases, and it's not technically cases, it's photos of people that have MPS, which is our abbreviated version for mucopolysaccharidosis. And as you see, they have a scale here from severe to attenuated, which I said before, attenuated is the less severe form. So here's severe, and these are two of the middle, like a middle ground, and this is the least severe. So you can see under it, it has the different names that I spoke about previously and how they correlate to the severity of the disease. So you have no impairment, and as I was saying before, you are able to live a fulfilling life and have this condition and not even know that you really have it. So you have here no mild mental delay or learning disability and your expected lifespan. And then this is your full-blown with your pronounced mental delays and your loss of acquired skills and your disease severity, and it gives you approximately a lifespan of about 7 years. And here are two more. So she is going to be on the attenuated side, and he's going to be on the middle ground. Here's some support groups and foundations, and under that I put in a couple of companies that do the genetic testing. The genetic testing on the previous slide with the costs are all associated with these three companies that offer genetic testing for MPS. And there's a support group, the National MPS Society, and it supports and educates families who have members diagnosed with MPS. And it's not just support and education, they advocate for these patients and push for research and new innovations that will be beneficial to these families and future families to come, to make life easier and not only educate the families but educate the public, so the public knows how to deal and look at these diseases without any hindrance or bias. Pretty much we just need education. So I included a video that I'm not going to play here because you can watch it on your own in the slide. But it's about mucopolysaccharidosis, and this should answer any further questions that you may have or things that I did not cover or were unable to fit in the slide, which I think I covered everything. However, this is just another way of explaining what this disease is, how it functions, the enzymes, and how the defected protein does not produce the enzyme, everything that it affects. So please take time and watch it.